All right, I want to show you how you can solve this. This is Electrostatics, Chapter 1 on Physics 102 workbook. So a friend of mine brought this for me to solve from A to Z. So I'm going to be showing you all the answers. Okay. Now you see how I solved my own. And from there, you make some necessary corrections. All right. So this is my Q1. This is Q2, which is equal to Q2. And then we'll have that Q2 is equal to 2Q1, 2Q2, sorry. And that R is equal to R. So when you look at this, you can see this formula here. This formula is for the formula for electrostatic force. This is a formula that you can apply anytime you want to solve this. So this is that F is equal to KQ1 Q2 over R squared. Right? So if you look at this, you bring it back down here. You have that KQ1 2Q2 divided by R squared. Okay? Look at this. If you look at this, you have that at this point, what I did is just to rearrange this, okay? And then you have this. So I want you to look at what I did here. It says that F is equals to 2F1. So the final thing you will write is that when we double the charge, you can say it. When we double the charge, the total flux is doubled. So this is just it. Take your time. And then before we go to the next page, I want us to go to the next chapter, which is chapter 2. This is chapter 1. This is exactly chapter 1, okay? Hope you are true. All right. Let's go to chapter 2. This is a solution to chapter 2. This is a solution to chapter 2. This is a solution to chapter 2. You have that my Q1 is equal to Q2. Q1 is equal to Q2. And that R is equal to 40 millimeter. Where F is equal to 0.5 Newton. And then R is equal to 40 millimeter. Then when you convert this is what you have. You are converting this to meters, okay? Good. Now from Coulomb's law, you have that F is equal to KQ1, Q2 over R squared. So we have to make Q subject formula. So when you make Q subject formula, this is what you are going to have, okay? And then when you have this now, you substitute the value of all this. I have to substitute flux here, okay? I have to substitute this. I have to substitute this, okay? I have to substitute this. So what I have here is this. So I want you to go through it and see how I solve this. So after solving this, please try to put this as Q is equal to plus or minus 2.98 exponential minus 7 coulombs. This is the answer. So I want you to just take your time. Take your time and copy this, okay? And then we go to chapter 3. Let's go to chapter 3. Okay. This is chapter 3. Let's go to chapter 3. So this is chapter 3, okay? I want you to draw the diagram. And after the diagram, you can see what to write. You can see exactly what you are going to write. This shows that Q1 is equal to this, and my Q2 is equal to this. This is R, and this is my R2 from the diagram, okay? So if you have this, you have that R1 is equal to 5 centimeter. Then when you convert this to meter, this is exactly what you are going to be having. And then R2 is equal to 3 centimeter, which is now equal to this when you convert it to meter. So you have to apply this formula. Look at this. You have to apply this formula. E1 is equal to KQ1 for you now to get the final answer. Okay? For you to get the final answer. Take a look at this. I want you to just take a look at this. Okay? So when you look at this, you see my solvings. And then finally, we have that EP is equal to E1 plus E2, which is equal to exactly what I have. So the direction of the electric field is to the left. The direction of the electric field is to the left. That is exactly what you are going to have. So let's go to question number 4. This is a solution to question number 4. This is question to number 4. You have that Q1 is equal to plus 30 coulombs and Q2 is plus 10 coulombs. And R1 is equal to 10 centimeter. R2 is equals to 10 centimeter. Then converting the 10 centimeter to meter, you have 0.1. And then R2, you convert it also. So after solving, at the end, you are going to have that your E1. You are going to have that your E1. Going to have that your E1 is equal to 2.7 exponential 13 Newton per coulombs. So when you look at it, since the two charges are positive, you have that the electric potential at P is now equal to E1 minus E2. It's now equal to E1 minus E2. So when you solve it, you will have finally that your EP, electric potential at P, becomes equal to 1.8 exponential 13 Newton per coulombs. Now there is a question that says, what is the direction? What is the direction of the electric field? So you can see our answer here. The direction of the electric field is in opposite direction. The direction of the electric field is in opposite direction. That's exactly what you are going to do. So this is all about question number 4. So let's look at question number 5. Question number 5. On question number 5, this is exactly what you are going to do. Question number 5, the question says a disk of radius 0.1 meter is oriented with its normal at angle of 30 degrees to a uniform electric field E with magnitude 2 exponential 3 Newton per coulombs. What is the electric flux through the disk? B. What is the electric flux when the electric field is parallel to the normal? C. What is the electric flux when the electric field is perpendicular to the normal? So from here, you see what I did. R is equal to 0.1 meter. Theta is equal to 30 degrees. E is equal to 2 exponential 3 Newton per coulombs. And then you use that A is equal to pi r square, which when you convert it, you have that this is 3.14 exponential. You can see it here. So the area is equal to 0.0314 meters square. Then let us solve the first question, which is electric flux through the disk. A. You use that the electric flux is equal to EA cos theta. Here, you have that flux is equal to 2 exponential 3 times 0.0314 cos 30 degrees. This is 2 exponential 3 times 0.0314 cos 30 degrees. And when you press it from your calculator, you have the final answer to be 54.38 Newton meter coulombs. Then B says electric flux. When the electric field is parallel, the formula for the electric flux should be equal to phi, which is equal to EA, which is equal to EA. You can see it here. This is a formula. Then from here, you have that phi is equal to EA. Then the electric flux is 2 times exponential 3 times 0.0314. So the final thing is 62.8 Newton meter square per coulombs. And finally, the electric flux. When the electric field is perpendicular to the normal is 0. The final answer there is equal to what? 0. So this is it. Okay? So let's go to chapter 2, which is conductors. This is chapter 2, which is what? Conductors and currents. Now, if you want to solve this, you find out that in this diagram, I try to reduce this diagram that making this one to be arrow 1, which is 50. This is arrow 2, 50. And this is my arrow 3, 50, arrow 4. You can see them 1, 2, 3, 4 here. So the terminal is from here, A to C, which is this terminal, from A to C, okay? Now, we now assume that these two persons are in series. If arrow 1 and arrow 2 are in series, and equally arrow 3 and arrow 4 are in series. So you have to get a combined resistors from here, which I reduce the diagram like this. Combined resistors here meaning that arrow 1 plus arrow 2, which is 50 plus 50 will give us 100. You can see this 100. Then this 50 plus this 50 will give us what? 100. So we call this one arrow 5 and we call this arrow 6. See where I did the calculation here that my arrow 5 is equal to what? Arrow 1 plus arrow 2, which is equal to 100 ohms. And that my arrow 6 is equal to arrow 3 plus arrow 4, which is equal to 100 ohms. So in this case, arrow 5 and arrow 6 are now in parallel. So these two persons are now in what? They are now in parallel. And you know when resistors are in parallel, this is the formula I'm going to use. 1 over the resistor AC that is in parallel is equal to 1 over this 100 plus 1 over this 100. So the LCM is 100. You can see it. And then finally, we have that the ROAC resistor is equal to 50 ohms. We have it to be equal to 60 ohms because the question says that determine the resistance the meter record when connected between the following corners. So when we connect this thing from here to here, which is from here to here, the effective resistance is 50 ohms. So the answer is 50 ohms. That is correct. This is the answer for this. So we go to the next question, or possibly in the next diagram. You can see it. You can see it. This is the next diagram. So you say we should calculate the resistance, determine the resistance when it moves from A to what? C. Sorry, from A to B. From A to B. So we reconnect this diagram in this format. This is 50, 50, 50. You can see this, which is 50 ohms. Okay, you can see it. And then 1, 2, 3 are in series. So because 1, 2, 3 are in series, the combined resistance will be equal to 150. You combine 1, 2, 3 in series. I said you combine 1, 2, and 3 in series. So you have the combined resistance to be 150, which is this. And this person that you are seeing here is this, okay? So this terminal is from here, A to B. You can see it here. So now reducing this diagram, you find out that these two persons now are now in, two of them are now in parallel. So when resistance or resistors are in parallel, we need to get the effective resistance by saying rho 1 over rho AB is equal to what? 1 over 150 plus 1 over 50. So when you solve this, see what I did here? See, are you seeing it? Then you have finally that the rho AB is equal to 37.5 approximately, which is 38 ohms. So this is how we can solve this particular chapter 2 on conductor. Okay, so let us go to the next one, which is the next page should be on question number 2. Okay, let us look at this question now. Let's look at this question. Okay, good. So from this diagram, question said that we should show that the resistance of the single equivalent resistors that could replace the 4 resistors between the points A and B is 50. That we should prove this. So when you look at this, you find out that the 30, this one is that the 30 ohm and the 60 ohm are parallel, and their effective resistance be R2. This is 30, this one and this one, they are parallel, okay? And we make their effective resistance to be equal to what? R2, which is this. So the effective resistance there of these two persons now will give us what? It's going to give us this solution here, which is equal to 20, because these two persons are in what? They are in parallel, okay? Now at the same time also, the 40 and the 120 ohm resistors are parallel. They are parallel. And when they are parallel, this is exactly what you are going to do. And then you have that R3 is equal to 30 ohm. Now, this is parallel. These are in parallel. These are in parallel. So when you connect these two persons now, these two resistors, and connect them to be in series, it therefore simply means that the equivalent resistor now becomes R2 plus R3, which will give me, since they are in series now, which is 20 plus 30. And the final answer is what? Is 50 ohms. So you see that we have answered this question that says that we should show that the resistance of the single equivalent resistors that could replace the 4 resistors between the points A and B is 50 ohms. Okay? So that is how we can solve that. And then there is another question here that says we should find, another question there says, if R1 is 50 ohms, calculate the current in R1. If R1 is 50 ohms, calculate, if R1 is 50 ohms, calculate the current in R1. So this is the solution here. Look at it. This is the solution here. You can look at the solution. The current in R1 can be calculated using the formula I is equal to V all over R1, which is now equal to the voltage V. Voltage V is 24. Check it, is given from the diagram. You can see it here. Sorry, from the question is given. Look at it, it's 24 here. So this is now 24 over 100. 24 over what? Over 100. Okay? This is 24 over 100, which will give me that, which is that my I becomes equal to 0.24. Okay? This is 0.24. That is exactly what I'm going to be having. Now this one is that the current in 60 ohm resistor. Let me calculate that. The current in 60 ohm resistor should be calculated. This is how you can calculate it. Okay? That's exactly how you can calculate that. You can see it. You can see it. Okay? You can see it. You can see it. So it is now, this is, the current is 0.080 amp. And then finally, you can look at this diagram and you picture the solution here and how I solved this. I've solved everything here for you. So you need to follow this YouTube channel. After this particular one now, you will see the next answer continuation. This is already on page, I think page 11. So this is how we can solve this one. Since the total current in the circuit I is equal to what? The formula is that you use E over RT plus R, where RT is what? 30 plus 30. You can see it is given 30 ohms. You can see this 30 here is given. Okay, you can see it. This is 30 plus 30, which is equals to 60 ohms. Then the EMOF of the cell is 12. You can see it here. It's 12 divided by 60 plus 2.0. So everything is going to give me 0.194 amps. So that is the final answer. Thank you and God bless you. Let's watch the next video, okay, to continue. Thank you.